Today we'll be doing differential equation, right?
Yes.
And however, I wanted to give you a couple of questions for the recapitulation, but uh, in between we will do that
Okay,
in
sir.
between the session. Okay, so differential equation. Differential equation is a kind of equation where you have a differential coefficient, an independent variable, and a dependent variable. No need to write the definition. We just need to know the differential equation consists of an independent variable, an independent variable, a dependent variable,
Hmm.
and differential coefficient, differential coefficients. That an equation like d2y over dx square plus 5 cos x cos by independent square and dy over dx. So we can this is a differential equation. Now coming to order and degree of order and degree of a differential equation of a differential. If this is second order derivative d2y over dx is square, so we can say this differential equation is of order 2. Okay,
Yes, sir.
so order of differential equation is that the order of derivatives, in fact. So in any differential equation, suppose we have three order of derivatives d3y over dx cube, then we can say the order of differential equation is 3. And what about degree? The degree of the degree is the highest, the power of the highest order. Degree is the power of highest, the power of the degree is the power of order of differential equation. Let us take an example. Suppose we have y triple dash 3x y double dash plus sine y equals to 0. the order is obviously 3. See, differential coefficient can be written any of the ways. Suppose we want to write 3 of the differential equation. Then differential equation can be written x cube or y. These are the various ways to write differential coefficient. Do you understand, David?
Yes, sir.
Do you understand?
Yes, sir. So can you hear me?
Am I not audible?
So can you hear me? Hello?
Okay.
No, sir. Your voice is breaking a lot.
Okay. So these are the various ways to write breaking a lot.
Yes,
What is
sir.
the reason for that? I am unable to understand.
I think my network is not good, sir. Let me just change it 1 minute.
Okay. 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 So here we have order is order of the differential equation order is degree is 2 as the power of highest order is 2. Power of highest order is 2. So degree is 2. Now when we have terms like sin dy over dx means any trigonometric function having angle as differential coefficient, then degree not defined. Then degree will not be defined. Dy over dx, then again degree. But make sure
Sir, your voice
if
is again
x,
breaking, sir.
And we discussed that degree of a differential equation will not be defined in case we have trigonometric function and their angle is differential coefficient like dy over dx or d2y over dx square like this. And also in the case of logarithmic function, if the function is dy over dx, then degree not defined. But here we have to make sure that suppose we have sine dy by dx equals to something like y, then dy by dx can be written as sine inverse y. Here degree will be defined if the trigonometric function has angle dy over dx differential coefficient, and that differential coefficient cannot be separated from sine, cosine function or tangent function whatever, then degree will not be defined. Okay, in that case degree will not be defined. So now what you have to do, turn over the page for first exercise 9.1. Write question number, order, degree. Okay,
Yes, sir.
from 1 to all, question number 12. 1, 2, 3, 4, 10. So write order, check the answer of the
So the first one is order
question.
is 4 and
What will be?
Yes, sir.
Order for degree.
Yes, sir. For the first question,
What is
order.
degree of
What, sir? Your voice is breaking. What did you say?
okay? Now this time I got it. It's from your side. I think there is some problem in your network because
Okay.
your voice is actually breaking now. So for order is
Oh,
4, degree is 1.
degree is one. Oh,
Degree
I
not
said not
1.
defined. I
Degree
said
not
not defined.
defined because it has, yes, 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 that will be answer. Degree not defined. In case of 2,
Yes, sir.
tell me the order and degree.
Order is one and degree is also one.
Yes. Order 1, degree 1. And third, in case of third question,
It is order is before.
third one,
Yes, the third one order will be four and degree will be one.
no, order is 2. 2
Oh,
only.
okay.
Order 2, degree 1.
Ah,
Order 2, degree 1.
I wrote four and then
Question
one. So,
4.
hmm. It is order is two and it is not defined, and degree is not defined.
Degree not defined. Correct. Question 5.
In this one, it is order is two and then the degree is one.
Mm, yes. Question 6.
The order is three and then the degree is two.
Yes. Question 7.
Order is three for this one also, sir, and then degree is one.
Yes, correct. Now, question 8.
Order is one and degree is one, sir.
1, 1. Yes. Ninth.
The ninth one is two. Order is two, sir, and then degree was one.
Yes. 10.
This is also order two and then degree one, sir.
Correct. 11th.
You want the order also, sir, for this one?
Yes.
Three order is three and the
Degree.
degree is not defined.
What is degree?
Degree is
Order
not defined,
is
sir.
2. Order is 2. Degree not defined.
Ah, okay.
Yes. 12th. 12th.
The 12th one, the order is two.
Order is 2, yes.
Hmm.
So we completed the first exercise. Now in exercise 9.2, we have in each of the exercises 1 to 10 verify that the given functions is a solution of the corresponding differential equation. So in left hand, we have function has been given, right? This,
Yes,
for
sir.
example, in question 1, we have y equals to e to the power x plus 1. And we have to verify that differential equation, this solution is for y double dash minus y dash equals to 0. Okay. So what we do, we differentiate the equation given, and then we try to get the solution in terms of differential equation given in the right hand side. So starting from question 1. Just a minute. So we have in each of the exercises 1 to 10 verify. Okay, question has already been read now. So we have question number 1 is y equals to e to the power x plus 1, and we have to verify that this is the solution for y double dash minus y dash equals to 0. So
Yes,
what
yes,
we
sir.
do? Differentiating with respect to x, we have dy over dx. E to the power x is e to the power x itself. Okay, let's take it. Equation 1. Again differentiating with respect to x, we have
You get
y
e power
double
x
dash equals to e to the power x.
and then e power x
Now
minus e power x equal to 0.
subtracting 1 from 2. Yes. So subtracting, yes, subtracting 1 from 2. We have y double dash minus y dash equals to e to the power x minus e to the power x. So we have y double dash minus y dash equals to 0. We have to obtain. So hence now doing question number 4th.
Okay, sir.
We have y equals to root 1 plus x square and y dash equals to xy over 1 plus x square.
Hmm.
So differentiating with respect to x, y dash equals to derivative of root is 1 over 2 root and derivative of 1 plus square as per the chain rule. So y dash equals to 1 over 2 root 1 plus x square times 2 x square. So we have x over 1 plus x square. 1 plus x square here. Okay, xy over 1 plus x square. So what we do, we y dash equals to x upon root 1 plus x square, multiplying numerator and denominator by
1 plus x
1 plus x square. So this becomes y dash equals to x plus x square. And what about root 1 plus x square?
root 1
What is root 1 plus x square? plus x square is y, isn't it?
Oh. Yes, sir. We wrote on top.
So in place of root 1 plus x square, we can write y. So
X,
xy
Y.
upon
Yeah,
1 plus x square, hence verified.
got it, sir.
This has been done. Number 6. We have y equals to x sin x, and to verify xy dash equals to y plus x root x square minus y square. Okay.
Yes, sir.
So let us take this as equation 1. Okay. And y equals, we have y equals to x sin x. Differentiating with respect to x. X is 1 into sin x plus derivative of sin x is cos x into x. So y dash equals to sin x plus x cos x. And we have to verify like x y dash. So multiplying both sides, multiplying
Both sides.
both sides by x. It becomes xy dash x. Yes. So how will we do? Let's take equation 2 over here. From 1, from 1,
Yeah.
y equals to x sin x. So y over x sin x by x. Y over x equals to sin x. And cos x will be root over 1 minus sin square x y over x square. So cos x equals over x. Now put the values of sin x and cos x in the given equation 2.
Okay.
Put in second equals to x sin x. X sin x. Sin x is what? Y over x. X into y over x plus x square cos x. X square and cos x is root over x square minus y square over x. So xy equals to y plus, and that we had to verify. We had to obtain xy dash equals to y plus x root x square minus y square. We got it. So hence verified. Now we will be doing question number 10. We have y equals to root square root of a square minus x square, and we have to show x plus y dy by dx equals to 0. So dy over dx differential with respect to x, root x is 1 over 2 root x. In place of x, we are going to be writing by the differentiation of a square minus x square. Derivative of a square is 0 and derivative of minus x square is minus 2x. So it becomes why? Because we have root a square minus x square is y. So in place y. And now cross multiplying y dy by dx equals to negative x, and bringing all terms together equals to 0. Hence, now question number in 11, the number of arbitrary constant. See, number of orders equals to the number of arbitrary constant.
Okay.
So if fourth order, then the arbitrary constant will be 4. So answer will be D part 4. Question number 12. The number of arbitrary constant in the particular solution. Particular solution, irrespective of their order, they do not have any arbitrary constant. Okay, because we replace C by the some constant. We replace C arbitrary constant by some constant. Okay.
Hmm.
So there is no arbitrary constant in particular solution. Got it?
Yes, sir.
Now we shall learn how to solve first order, first degree differential equation. Okay. So we have actually different ways to solve first order and first degree differential equation.
Okay.
Any first order, first degree differential equation first order and first degree differential equation is of the type differential equation of the dy over dx, okay, equal fxy. And in differential equation of this form, dy by dx equals to fxy is said to be the first order degree differential equation. So if we have first order first degree equation, then the first method that we use to solve is variable separation equation. Variable, we write let's say gx two functions. This single function can be written as function of x and function of y. Bring hy function, bring function of y with dy so dy over hy and gx dx. And then we find the antiderivative.
Sir, can you
Finding
say again?
antiderivatives. Antiderivatives means integral. So this will be dy over hy equals to gx dx. We get the integral hy equals to g of differential equation. The differential equation passing through a given point or x value and y value given. Then in that case we substitute for x and y. We shall put and then we will find value of c. So this is the method used to solve the differential when we can write gx into hy means suppose we need to find the differential equation. dy over dx equals to find question is find the general solution find the general solution of differential equation dy over dx equals to dy over dx equals to 1 plus y square over 1 plus y square over 1 plus x square. So how will so we will bring with dy and x function with dx. Which is means we will integrate y plus x y minus x upon 1 plus yx. How we have written, do you know? It is
So can you explain again, sir?
an identity of inverse trigonometric. Exercise 9.3. For each of the differential equation in exercises 1 to 10 of the given differential equation. So first question is dy over dx equals to 1 minus cos x over 1 plus cos x. Now we can use the identity 1 minus cos x is 2 sine square x by 2. This is an identity. And 1 plus cos x is 2 cos square x by 2. 2 will be cancelled out. And here we have 10 square x by 2. Sine over cos is 10. So dy can be written as by x by 2 dx. Now integrating both sides, taking anti-derivatives on both sides. Now we are going to discuss question number 10. Question number 10. It is e to the power x 10y, e to the power x 10y dx plus 1 minus e to the power x sec, sec square y dy. Sec square y dy equals to 0. Okay. So
Yes, sir.
first what we do, we bring, we separate the terms. So we have e to the power x 10y dx equals to minus 1 minus e to the power x sec square y dy. So bringing all x terms with dx and all y terms with dy. So we have e to the power x dx over 1 minus e to the power x equals to minus sec square y dy over 10y. Integrating both sides, integrating both sides. E to the power x dx upon 1 minus e to the power x equals to minus sec square y over 10y dy. In the right hand side, we have f dash y over fy.
Hmm.
Means if we take 10y as t, we get sec square y dy equals to dt.
Okay, sir.
So when we have such form, then we have always integral is log of the function fx or fy, whatever. So, and in the left hand side, put 1 minus e to the power x equals to t. Then we have 0 minus e to the power x dx equals to dt. So we have e to the power x dx equals to minus dt. And in the right hand side, put 10y equals to z. So sec square y dy equals to dz. So this will become minus dt over t, and here it is minus dz over z. So minus sign will be cancelled out from both sides. So log t equals to log z plus log c, or c only. So log t means log 1 minus e to the power x equals to log 10y plus log c. So we have log 1 minus e to the power x equals to log c 10y using log property of log. Do you understand, David?
Yes, sir.
Okay. So removing log from both sides, we have 1 minus e to the power x equals to c 10y. This could be the simplest answer.
Okay.
Now I am giving one question to you.
Yes, sir.
Okay? Question number 11 we are going to do now. We have x cube plus x square plus x plus 1 dy over dx equals to 2x square plus x, y equals to 1, x equals to 0. So we can write this way: dy over dx equals to 2x square plus x divided by x cube plus x square plus x plus 1. And now this can be written as dy over dx equals to 2x square plus x divided by, take x square common in these two terms. So x square common x plus 1 and 1 common x plus 1. So this will be dy over dx equals to 2x square plus x upon x plus 1 into x square plus 1. This way. So now we can use partial fraction method. Before that, we have to write dy equals to 2x square plus x, x plus 1, x square plus 1 dx, and integrating both sides.
Mm.
Integrating both sides. So we have y equals to, let's say I, okay, and I equals to 2x square plus x upon x plus 1 times x square plus 1 dx. So we can write 2x square plus x equals to a upon x plus 1, x square plus 1 equals to a upon x plus 1 plus bx plus c upon x square plus 1. This is called partial fraction method to find the integral.
Mm.
David,
Yes, sir.
integration we haven't done, but I believe that you must have done previously and
Yes,
you
sir.
have basic ideas of all the chapters,
Yes, sir.
right?
Do have a basic idea.
Yes. So this is called partial fraction method to solve the integral. So differential equation have lots of integral work in fact, integration and differentiation. That is why it is called differential equation. And
Got it.
solution of it is obtained by integrating. So we have a over x plus 1. Yes. So we can write 2x square plus x equals to a times x square plus 1. See, this is the standard form.
Okay.
We have one linear and another quadratic in the denominator. So
Mm.
for linear, we take just a over x plus 1. And for quadratic, we have to take bx plus c in the numerator.
Okay.
Okay.
Got it, sir.
Plus bx plus c times x plus 1. And the denominator will be cancelled out if we take the LCM,
Okay.
right? Yeah.
Yes, sir.
So we have 2x square plus x equals to a x square plus a plus bx square plus b plus cx plus c. Now we can write 2x square plus x equals to a plus bx square plus b plus cx plus a plus c. Now equating the coefficients from both sides. equating the coefficients from both sides. So x square, coefficient of x square is a plus b, and in left hand side 2.
Okay.
And coefficient of b plus c is, coefficient of x is b plus c in right side, and in left side it is 1. And a plus c, constant term.
Okay.
There is no constant term in the left hand side. So a plus c is 0. So this is the method we use. We have to find the value of ABC, and finally we can place the value of ABC to find the integral.
What, sir?
So from 3 we have c equals to negative a. Okay, so put over here c equals to negative a. So from 2, b minus a equals to 1, and b plus a equals to 2 from 1. Okay, and add them. 2b equals to 3, b equals to 3 by 2, and b is 3 by 2, and a will be, a is 2 minus b, 2 minus 3 by 2, that is 1 by 2. And further we have c equals to negative a.
Hello, sir.
Negative 1. Yes,
Okay.
the value of c is negative 1 over 2. We have just got the values of a, b, c by solving the equations, nothing else. You can
Got it, sir.
do either of the ways. I mean, solving equation could be the different method.
Mm.
We have just put the value of c in equation 2 to get b minus a equals to 1, and equation 1 we have a plus b equals to 2, this one, and we added them to get the value of b, and then we put the value of b in equation 1 to get the value of a, and c we have negative a.
Okay, sir.
So finally we need to put these values over here,
Okay.
ABC, and we will write in place of the whole integral.
Got it, sir.
So integral will be a upon x plus 1,
Mm.
a upon x plus 1. So a is what? 1 over 2. So take 1 over 2 outside, 1 upon x plus 1 dx, and plus bx plus c. B is 3 over 2. So 3 over 2 x plus c. C is negative 1 over 2 divided by x square plus 1. So whole integration has been converted into this form now. And it is very easy to find the integral of this one. So half log x plus 1 will be there, and plus 3 by 2 x over x square plus 1 dx, and minus half 1 over x square plus 1 dx. If you take x square plus 1 as t for this one, you will get 2x dx equals to dt, and x dx is dt over 2. So the integral will be half log x plus 1. This is little bit, difficult sum, lengthy sum of differential equation, because you have to do lots of work in integration. So
Wow.
half log x plus 1 plus 3 over 2 and 1 over 2 dt by 2. So dt over 2 and dt by t. So that will become log x plus 1. So further we can write this, 3 over 4 in place of 3 over 2. We have 3 over 4 log x square plus 1 and minus half tan inverse x. Integral of 1 over x square plus 1 is tan inverse x.
Okay.
David.
Yes, sir.
So can you hear me?
Yes, yes. Is it little bit difficult?
No, sir. I'm just like processing everything over there, but it's not difficult to understand, sir.
Okay. Plus c.
Hmm.
So you just need to place the values in place of integral. Where is it? Here in equation 1. So
Okay.
finally you have to write y equals to, even now work is remaining in fact, y equals to half log x plus 1 plus 3 over 4 log x square plus 1 minus half tan inverse x plus c.
Okay.
And now for c, you have been given, in question you have been given x0, y1. So put x0, y1, 0, 1. So y equals to 1 equals to half log 1 plus 3 over 4 log 1 minus half tan inverse 1. Okay. So this is 1 equals to log 1 is 0. So this is 0. This is also 0 and this is minus half into tan inverse 1 is pi over 4
Hmm.
plus c plus c. So c is what? C is 1 plus pi over 8. Put the value of c and get the result, whatever you get.
Okay.
Simplification can be done with the different approaches and you can get the different values. Okay?
Okay.
Different form of differential equation. That's
Got it,
not
sir.
an issue. Again, I have another class. I had another class at 11 o'clock. I am getting late, so
Oh,
quickly I
okay.
have to leave you.
Okay, sir.
Okay?
Thank you, sir. Yeah, sir. Just
Welcome.
send me the PDF of this.
You will get all these things.
Okay. Yes. Thank you, then. Thanks, sir. Bye, sir.